In this video, we're going to look at the primary trigonometric ratios, or the primary trig ratios. Given a right triangle, we have three ratios we can look at: the tangent ratio, the sine ratio, and the cosine ratio. And the primary trig ratios are exactly that. They're the ratio of two sides. So the tangent ratio of an acute angle is the length of the opposite side of that angle divided by the length of the adjacent side. Or simply, tangent of angle A is opposite over adjacent. The sine of an angle is the length of the opposite side for that angle divided by the length of the hypotenuse. Or sin A is opposite over hypotenuse. And finally, the cosine ratio of acute angle is the length of the side adjacent that angle divided by the length of the hypotenuse, or cosine A equals adjacent over hypotenuse. So there's a mistake there. So adjacent over hypotenuse. Alright, so for example, let's say I have the following triangle. So if we focus on angle A, and first of all I want to know what side is opposite angle A, what side is adjacent, and what side is the hypotenuse. Well, we all know the hypotenuse is across the 90-degree angle. Opposite angle A is side BC, so this is the opposite side. And then only thing that's left is adjacent. Adjacent means beside it. So beside angle A is the hypotenuse and what we call the adjacent side. So we have the side opposite angle A, the side adjacent angle A, and the hypotenuse. Now when we label triangles, across angle A is what we call side A, and we give it a lowercase letter. Across angle C is little c, and across angle B is little b. So let's label the other one the same way. Now if we focus on angle B, the hypotenuse is still the same. However, we see across angle B is side B, and this is now opposite angle B, which means that this side here, BC, is adjacent angle B. So this is just to help us name the sides that we're looking for. So if I want the tangent ratio, so the tangent of angle A, or if I want the tangent of angle B, remember tangent is opposite over adjacent, opposite over adjacent, the angle you're focused on. So for our first example, if we look at angle A, opposite angle A is side A, and adjacent to angle A is side B. So there is the tangent ratio, would be whatever side A is divided by side B. If we're looking for angle B, if we're looking for the tangent of angle B, the opposite this time is B, and the adjacent side is A. So this time if we take side B divided by side of A, we get the tangent ratio, the ratio of opposite over adjacent. So next we can do the sine. So the sine of angle A is the opposite over the hypotenuse. And if we look at the opposite side to angle A, that's A. The hypotenuse is C, so this is A over C. And if we do the sine of angle B, well, that would be B. Opposite B is angle B divided by the hypotenuse, which is C. And the last one, if we look for the cosine ratio is just the adjacent side length over the hypotenuse length. And the adjacent side length to angle A is B divided by the hypotenuse C. And if we want the cosine of angle B, that is going to be A over C. And that is all these ratios are. You're given a certain angle and you find the ratio between the two sides. This is important because we've been talking about similar triangles. So if we go back to a set of similar triangles, so let's say these two here. I note for any triangle, let's call this triangle ABC, and this one ABC as well. that if I want the tan of angle A for the first triangle, that's opposite over adjacent, that's 4 over 3. So remember, this is opposite angle A. This is adjacent angle A. And if I do the same thing for the big triangle, the tan of angle A is 8 over 6. So since these are similar triangles, that one is twice as big as the other, I see that the tangent ratio, no matter what size triangle I take, as long as they have the same angle and are similar triangles, the tangent ratio we see is the same. And we're going to see why this is important in a moment. Alright, so let's look at some special buttons on your calculator. So you should be able to find 3 buttons on your calculator: sine, cosine, and tan. So take a look for those. The second thing is to make sure your calculator is in degree mode. So up in the screen somewhere, you should see a DEG, or just a little d. If you don't, then you need to adjust your calculator. If you see an RAD, radian, or a little r on your screen, or if you see a G radian, a gradian, or a G at the top of your screen, you need to change these two. You don't want to be in this mode. You want to make sure that you're in this mode here. Make sure your calculator is in degree mode. If you're unsure, or it's not in the right mode and you don't know how to change it, send me a picture of your calculator and I'll try to explain how to change your calculator into degree mode. If it's in degree mode, this is what should happen. If I type in the tan of 52 degrees, you should end up with 1.280 approximately. And we'll talk about what that means in a moment. If I type in sine and 52 degrees, so let's try that one, you should end up with 0.788. And if I type in cosine of 52 degrees, so cosine of 52 degrees, you should end up with 0.616. If you don't get these numbers, let me know and we'll try to fix the problem. What does this all mean? So this is saying that you have a triangle with a 52 degree angle in it. So let's draw a triangle. And we're focused on a 52 degree angle. So let's start with the sine. The sine of 52 says 0.788, which is 0.788 over 1. And sine is equal to the opposite over the hypotenuse. So if that is angle 50, if we have angle 52, remember this is our opposite side, this is our hypotenuse. So that means that this side length has a ratio of 0.788 to the hypotenuse value of 1. So any triangle that's 0.788 for its opposite side and a ratio of 1 for its hypotenuse will have 52 degrees as its angle. So this could be 788 versus 1,000, right? The hypotenuse could be 1,000. The height of the triangle could be 788 units. The cosine is telling you that your adjacent side is 616.616 and your hypotenuse is 1. So it's telling you that this side is 0.616 and your hypotenuse is 1. And if you look at this, 0.788, if you use Pythagorean theorem, if you took 0.788, squared it, added it to 0.616 and squared it, you should get very close to 1. And sorry, this is the adjacent side. That's what the sine and cosine are telling you. The tan is saying that if I take my opposite side, it is 1.280 versus my adjacent side, which is 1. So let's look at what that triangle looks like. So it's the same right triangle, 52 degrees, except that tan is saying this is 1.280 and that this is 1. Well, this is actually the same as the triangle we've drawn here on the left. These are the same or similar triangles. If I take 1.28 and divide it by 1, that gives me 1.28. That's on this triangle. 1.280 divided by 1 equals 1.280. Well, if you take 0.788 and divide it by 0.616, notice that is well, it's a little bit off, but it's about 1.279. Very close to the same number here. So you can see I've just created two triangles with 52 degrees as their main angle, and they're both similar triangles because they have 52, 90, and of course the last angle you can figure out using the 180 rule. That is what these ratios are giving you. So your calculator converts an angle in a triangle into a ratio of the sides. So it tells you if you have a 52-degree angle in your triangle that the ratio of the sides are shown here. 1.28 over 1, 0.788 over 1, 0.616 over 1. All right, so let's do the last one. Let's figure out the tan of 28, see if your calculator is in the right mode, sine of 28, and cosine of 28. So here I get approximately 0.532. And then for the sine of 28, 0.469. And then for the cosine of 28, 0.883. 0.883. So thinking about what these ratios are, for what angle will sine and cosine ratio be equal? Remember that sine of an angle A is opposite over hypotenuse, and cosine of an angle A is adjacent over hypotenuse. So the question is asking, when will these two things be equal? The cosine and the sine. And if you look closely at it, to be equal, since they both have the same hypotenuse, or share the hypotenuse as part of their equation, the only time they'll be equal is when the opposite side is equal to the adjacent side, or when you have an isosceles right triangle. So if you have a right triangle in which this side is equal to this side. So let's say this is 5 and this is 5, and if you're focused on this angle down here, so that the opposite over the hypotenuse, so this hypotenuse here would be the square root, if you use the Pythagorean, the square root of 50. So the sine of angle A is opposite, which is 5, divided by the square root of 50. And the cosine of angle A, which is the adjacent side, is 5 divided by the square root of 50. Remembering that, this is the hypotenuse. This is the opposite of that angle here. And this is the adjacent side. So again, they'll be the same if we have an isosceles right triangle, which means that this angle must be 45 degrees. Since this angle must be 45 degrees, since we have an isosceles right triangle. So any triangle with 45 degrees, any right triangle with a 45-degree angle will give us a sine and cosine ratio that is the same. So let's practice this a bit more. I want to know what is the sine of angle D and the cosine of angle D, and then what is the angle. So again, we're focused on a particular angle. We're focused on this angle here, angle D. And remember, the sine of angle D is equal to the opposite side length over the length of the hypotenuse, and the cosine of angle D is the adjacent side length over the hypotenuse. We have the lengths of the legs of the triangle. However, we need the length of the hypotenuse for part of this ratio. So let's first find that. That would be side F. Remember, across capital F is little f. So we have f squared is equal to 15 squared plus 8 squared. So side F is equal to the square root of 15 squared plus 8 squared. And if you solve for that side length using your calculator, you should end up with that f is equal to 17. and this would be side E, and this would be side little d. So now that we have all three side lengths, we see that the sine of angle D is the opposite over the hypotenuse. So that is, opposite is 8 over the hypotenuse is 17. So let's add that here. This is opposite angle D. This is adjacent angle D. And of course, this is our hypotenuse across the 90-degree angle. Cosine of angle D would be the adjacent side, so that'd be 15 over the hypotenuse of 17. So we've answered this part of the question. We found the sine ratio and the cosine ratio. The good part about this is your calculator could convert these ratios into an angle. It knows that a triangle with a ratio of 8 over 17 has a particular angle. Similarly, it knows that a triangle with a ratio of 15 over 17, it has a particular angle attached to it. So on your calculators, you're now going to find D, the angle, or we'll call it angle D. And what you do is, so here's sine. If I want to undo the sine, I apply what's called the inverse. So the inverse of the sine is a sine with a little -1 there. Think of x squared. The inverse of x squared is square root. How you undo a square is you square root. How you undo multiplication, you divide. How you undo what's called a sine ratio, you do the sine minus 1. And so on your calculator, and make sure you have a bracket here, you're going to do the sine minus 1, which is a special button on your calculator. And then you're going to type in brackets 8 divided by 17 and hit enter. So on my calculator, I hit, it's usually a second button, sine minus 1, 8 divided by 17. I'm going to close the bracket, and it's going to give me an angle of approximately 28 degrees, which is great. It's telling you that a triangle with an 8 over 17 ratio of opposite to hypotenuse has to be a 28-degree triangle. We can do the same thing for cosine. If I want angle D, I'm going to do the cos minus 1 of 15 over 17. And if I do that, I again get 28 degrees, which should be the same because we're focused only on angle D. So whether I use the cosine ratio or the sine ratio, I should get the same answer, which is 28 degrees for that angle D in this right triangle. Is there another way to determine angle D? Well, there sure is. We talked about the third way. We can do the tan ratio of angle D. And remember, tan is opposite over adjacent. So tan is the opposite side over the adjacent side. And the nice part about using tan is we didn't need the hypotenuse, so we didn't actually need to calculate it. And our opposite was 8 over 15. So let's write that in. So we have 8 over 15. And so if I want angle D, I could also do the tan minus 1 of 8 over 15. And let's see what we get. So hit your second function button, and then find your tan minus 1. 8 divided by 15, again, gives me approximately 28 degrees. So we have three ways we can find an angle given the sides. We can find an angle by using the sine ratio, the cosine ratio, or the tan ratio. And that is because your calculator takes that ratio and converts it into the angle for the corresponding triangle. So let's look at examples where I can now solve for a side length or an angle given any right triangle using these ratios. And there are three steps we're always going to do. First step, label your diagram. And what I mean by label is clearly identify your sides that you're focused on and your angles and what they are called. So we're focused on this 35-degree angle. We're always focused on an acute angle. And relative to this acute angle, x is of course our hypotenuse. And the 102, the only side that we know, is adjacent to that 35 degrees. So that's how we start. We start by labeling our diagram. Second thing, we need to identify the ratio. So since we have the words adjacent and hypotenuse, only one of those ratios have the adjacent and hypotenuse in it. And if you look for that, that would be the cosine ratio. So we have the cosine of some angle, let's call this A. Cosine of A is equal to adjacent over the hypotenuse. Okay, and let's label the rest if we like, B and C. And in this example, we know angle A. So once we identify the ratio, we solve the problem. So we substitute and solve. Okay, so cosine of angle A. We go over here, we have angle A. It's right there, 35 degrees. So we have cosine of 35 degrees, which our calculator can determine the side lengths, is equal to, well, let's start with the adjacent. Remember, cosine is adjacent. Adjacent is 102 meters, and the hypotenuse is x. So now we need to solve this equation. Problem is that x is in the denominator. So remember, this is a number, cosine 35. If you type it into your calculator, it'll give you a ratio. This is cosine 35 over 1. Most students like to solve this using a method called cross multiplying. So take the denominator and multiply both sides by that denominator. And if I do so, I end up with x cosine 35 is equal to 1 times 102 is 102. And then the last step, I need to solve for x, so I'm going to divide both sides by cosine of 35 to get x by itself. So I get x equals 102 divided by the cosine of 35. So these cancel. And the rest is calculator work. So you're going to type in 102 divided by the cosine of 35 degrees. And you should end up with approximately 124.5 units. And the units are meters, so 124.5 meters. So without having to measure, use a protractor, we figured out the length of side x using a cosine ratio. Let's try this again. So here's the next one. Start with the angle that we're focused on. That's this angle here, 55 degrees. Again, we know this is the hypotenuse. This x here is opposite 55, so that is opposite angle. If we want, we call that A again. So this is A, B, and C. So this is opposite angle A. So we look for a ratio that has the hypotenuse and the opposite angle. The opposite has the hypotenuse and the opposite side. And that one is sine. So the sine of A is the opposite over the hypotenuse. And if we want to solve that, we know that the angle this time is 55 degrees. The opposite side is x, and the hypotenuse is 7. Remember, this is sine 55 over 1, so if we want to use the cross multiplying technique, we're going to multiply the left side by 7, the right side by 1. This one's nice and simple. We get 7 sine 55 equals x. No dividing after this because x is on its own. So on our calculator, we're just going to type in 7 times sine 55. 7 times sine 55. And here we get x is approximately equal to 5.7 centimeters. So label your diagram, pick the ratio that you need, and solve for the variable. Let's try one more. This time, I have an angle that I want to solve for. So let's call this A if you like, B and C. I have two side lengths that I know. So this is opposite angle A, because, and this one must be adjacent angle A because it's right beside it, and we know that's not the hypotenuse. Here is our hypotenuse. But we don't know the hypotenuse. We only know the adjacent side and the opposite side. So let's pick our ratio. Our ratio that works for that is tangent tangent of A, remember, has the opposite side divided by the adjacent side. And so if we want to solve that, instead of A this time, we have this fancy symbol called theta. So the tan of theta is equal to the opposite side 15 over the adjacent side of 10. And remember, when I want to find an angle, I got to look for the inverse of tan. So tan minus 1, I got to get rid of the tan and find the tan minus 1 of 15 over 10. So you only use this tan minus 1 or cos minus 1 or sine minus 1 when you're looking for an angle. The rest of the time, you just keep it the way it is. And if you type this into your calculator, you should get that the angle is approximately 56 degrees. So if you had a triangle that had a opposite side of 15, adjacent side of 10, or a ratio of 15 over 10, that angle it would create is 56 degrees. So we have two things when using these ratios. We can find a side length by finding the correct ratio, cross-multiplying and solving for the missing variable. And in that case, we don't have to do the sine minus 1, or we need to find an angle. So we have to be given two sides, decide what ratio corresponds to those two sides, and then do the inverse tan, the inverse sine, or the inverse cos of that ratio to get back our angle.